are you ready for the event?
Houston, this is Station. We are ready for the event.
Cool Science Radio, this is Mission Control Houston. Please call Station for a voice check.
Station, this is John Wells and Lynn Ware Peak with Cool Science Radio. How do you hear me?
We hear you loud and clear. How about us?
We hear you loud and clear. Good morning, gentlemen. I'm going to give a brief introduction, and we will start all of this. From the NPR studios of KPCW in Park City, Utah, this is Cool Science Radio. I'm John Wells. I'm here with Lynn Ware Peak, and I'm here with Sophie O'Connor, our 10-year-old science friend from Park City's Trailside Elementary School. Our guests this morning are NASA astronauts Shane Kimbrough and Mark Vande Hei, who are 270 miles above the planet Earth on the International Space Station, which is traveling at 17,500 miles per hour. Shane and Mark, a big welcome to Cool Science Radio.
It's great to be here.
Well, it's great to have you here, and we're delighted to have you on the program this morning. We have a bunch of science questions, but I want to ask a question that's not too sciencey. First, you both have extensive backgrounds in education. You have postgraduate degrees in science and applied physics. You both have overseas military service to our country, and you have multiple space flights with over 200 days each in space, not to mention a bunch of spacewalks. We don't really have the time today to go into the detail of each of your records, so I'll just say that you're both, let's say, overachievers. So my question's this. What informed and motivated you during your childhood that brings you front and center to America's space program today?
Wow, that's a really good question. I would say a sense that if I wasn't doing well enough, that it was my responsibility to try harder, that I believed I really could do anything if I worked at it hard enough. Now, certainly as I got older, I realized that either there were some things that were beyond my capability or maybe the time on the return on investment wasn't worth the effort. But certainly as a kid, I knew that it was all about the work I put into things that determined my success.
Well, good morning to you. This is Lynn Ware Peak, co-host of Cool Science Radio, Shane and Mark. We're so excited to talk to you this morning. I wanted to ask you about technology. So as technology evolves and advances, even something like installing a new toilet can bring, well, I would say a much more comfortable way of life in the ISS. Can you tell us about this recent installation of the new toilet? I mean, even in the world of toilets, there have been many off-grid improvements. How does this translate when you're doing it in space?
Well, toilets are very useful up here, just like they are on Earth. Mark and I have gotten, I guess, the pleasure of working a lot on the new one that we installed here probably about a month ago now. It is not functional yet. The hardware's in place. We're still working on a few things to make sure it's completely functional for the rest of the crew and us, but it's a nice capability. It's this toilet that we're testing out now, it actually is a test because it's going to be used on the Artemis missions, the missions going to the moon. So we want to test it out here, make sure it works really well for our colleagues that are going to be taking it to the moon later on.
I'm Sophie O'Connor. I'm 10 years old from Park City's Trailside Elementary School. I'm honored to meet you today and to be here with Lynn and John Wells. I love science, and I'm very happy to be talking with you this morning. My first question is, if you are in zero gravity, how do you sleep and make sure you get a good night's sleep?
We all have sleeping bags, and for me, I just have my sleeping bag shoulders attached to the wall, and once I got used to floating, while I'm sleeping, it's actually some of the most comfortable sleep you can get from my perspective. I think people on the Earth try really hard to recreate this sense of floating that we get in space very easily.
Mark, this next question is for you. Many people view our planet from the perspective of a Rand McNally map with 195 separate countries. As you view our planet with geographic borders and you observe the small and delicate ribbon of atmosphere that keeps us all alive, how has that shaped your thoughts about our home planet, Earth?
Well, we have an incredible perspective, as you might imagine, from up here. Our planet is spectacular. It's fragile, and that's the part that we see up here, that thin layer of atmosphere that you were talking about. So to me personally, it just made me want to take care of our planet when I'm back on Earth. It's given me a different perspective to think about, taking care of our planet. Now, it's really cool for us up here to know that we have instruments on the outside of the space station that are watching climate change and looking at the ozone and things like that. So we are still kind of part of all that stuff because we're part of the space station. So definitely want to take care of our planet. That's number one, so that we can continue to live like we know, like we have been living over the last several centuries.
Right. Well, taking care of the planet is one thing, and then taking care of the health of your own bodies is another thing. Shane, how about this for you? Is there any one thing that you've noticed about your own health that you possibly have not felt before on previous missions?
Well, I've done a long-duration mission before, so in general, things are pretty similar. I had a few aches and pains the first week or so as your body, or my body, was adapting and growing. We grow about, almost up to 2 inches sometimes when we get to space because we don't have gravity pulling down our spine. And so that gave me a little bit of a lower back pain the first couple of weeks, and it happened on both of my flights. This one, I don't feel anything different. I would say I'm a little older, of course, so maybe the workouts hurt me a little more, but I think that's about it.
Do you have to worry about meteors or space junk hitting you in space?
Fortunately, the developers of this spacecraft had that environment in mind, the fact that there is space junk that we could collide with, when they made the spacecraft. So it's designed to protect us from that. However, in the unlikely event that something actually does penetrate through the spacecraft and cause a depressurization, we train really hard to make sure we understand how to react to that so we can save ourselves and the spacecraft. So it's not something I worry about routinely because other people have put a lot of effort into making sure we're both ready for it and the spacecraft is ready for it.
If you're just joining us on Cool Science Radio, a big welcome to our listening audience and also to the viewing audience from NASA TV. We are having a conversation with Shane Kimbrough and Mark Vande Hei, who are 270 miles above planet Earth and the International Space Station, which is traveling at 17,500 miles per hour. Shane, this question is for you. As you add new modules and functionality to the International Space Station, what does the future look like for the International Space Station?
Well, you may have heard we just got a new module last week. The Russians added a new module onto their part of the space station. And besides that, that's probably the last module I think that's going to get added, at least for quite some time. But all the things that are up here, and this place has grown since the first time I was here back in 2008, many modules have been added, and it's all really to either help people on Earth or help our future explorations. So all these modules that we're adding, we're trying to get technologies down and other things that are going to help us as we go to the moon and beyond.
Oh, it's so exciting. And in talking about modifications that you're making to the space station, you had a few spacewalks back in June to put out new solar arrays. We put more and more solar arrays on our homes here in Park City and beyond. How are those replacements doing? Do they bolster capacity for the chores of the station? And how may they vary from a solar array that we have on our own homes? Mark, if you want to take that.
Sure, I'll take it. I got to highlight the fact that Shane actually went outside and did those EVAs. I was on the inside making sure they were well supported with the task to get them out the door. But those solar arrays are certainly improved technologies over the solar arrays that we had previously or that are still out there. And it increased the capacity of our energy generation system, or of our electrical power generation system. I would say a major difference between the solar arrays we have on the space station and the one that you might have on your roof is they don't have to be very rigid. The structures that hold them in this nice spread out shape aren't nearly as strong. I shouldn't say, I can't compare the relative strength of them, but they certainly take this environment in mind where we're all in a free fall together. So if the vehicle is going to thrust, we have to go ahead and make sure they're in a situation where they can withstand that motion, for example. And when you're doing a spacewalk, you got to make sure you don't push on it too hard so that you don't damage it just with your body flopping it around.
Wondering, do you have a sunrise and sunset? And if not, how do you know when to go to sleep?
Yeah, thanks for the question. We have 16 sunrises and sunsets every day, believe it or not, because we're going around the Earth every 90 minutes. So we do have some windows up here we can look out. There's two right behind us the shutters are closed right now. But that's one way we can monitor if the sun's up or down. We can also look on the computer. We have a map that'll kind of show you if the sun's out or not. But, how do you know when to go to sleep? We just know by our timeline. So everything's driven by mission control, and they tell us when to get up and when to go to bed. But in general, we get up about 6 a.m. and we go to bed about 10 p.m.
Shane and Mark, we are very excited about the upcoming Artemis mission, and there are a number of pieces to it, including eventually having an orbital station that will be going around the moon, and then one day maybe going around Mars. How will the functionality of the orbital station around the moon and eventually Mars differ from the International Space Station, which orbits the Earth?
That's another fantastic question. I'm really excited about that future. So home base for us is the Earth. And when vehicles leave the space station, they're returning to the Earth. When we have a vehicle in orbit around the moon, and some of those departures from that space station will be to the moon. So it's going to be a very different dynamic. That's going to be, instead of it being a place we come to as a final destination, it's going to be a waypoint en route to the moon. So I think that'll make it'll be a huge difference in the way we use the space station.
That's really exciting. Talking about using the space station, I wanted to move in to talk about your female compatriot, shall we say, astronaut Megan McArthur. Can you talk about the relative benefits of having a female astronaut on board, and how often are they on board?
Well, first of all, having Megan on board is incredible. She's such a great crewmate and friend, and keeps us all in line. Let me put it that way. But in general, diversity is inherently a great value, especially in our line of work. It's always great to have people look at situations and solve problems from different perspectives. So that's just another one that we're happy to have. I've been very fortunate on all three of my space flights to have several women on each flight. And we don't think of them as female and male. I think we just think of them as crewmates and astronauts and friends.
Can you light a match or have a fire in outer space or in the space station?
We can. In fact, inside the space station, we have some research we do on flames and combustion. We have a combustion facility. Because the fire triangle requires fuel, oxygen, and an ignition source, when you're out in space where there's no oxygen, you're not going to have a fire. But inside the space station where we need oxygen to survive, yes, you could have a fire. The nice thing for us up here, though, is it's actually hard to keep a fire going because on the ground, those combustion gases are hot and will rise because of buoyant forces, get shoved out of the way by those cooler, heavier, oxygen-rich gases, and the flame continues. But in space, we don't have those buoyant forces. Again, we're all in a free fall. So the flame will look much more like a sphere, and it's hard for those oxygen-rich gases to get inside that sphere of combustion gases.
Shane and Mark, I have a question that either of you could answer, or both of you. and that is, what one question about science or spaceflight would you like to have answered that just has not been answered yet?
That's a tough one. We haven't had that one before. You've stumped us. Let us think about that for a minute. If you have another one, fire it off, and then we'll maybe come back to that.
Yeah, I'd like to talk about smoke. There's the Dixie Fire. There's a number of fires because it's just that time of the season. How does the Dixie Fire look?
Yeah, we go around the planet, like we said, very quickly, and a lot of us are taking a lot of photography out of the windows, and over the last couple of weeks, we've seen fires everywhere, from the United States to Russia to Canada, and they look devastating from our perspective. Of course, we know what they're doing on the ground, and our hearts go out to all the people that are getting affected by those fires, of course. But yeah, it's a thing of nature, of course, in a lot of cases, and it's another thing that we can view, and I actually have sensors up here that we can maybe help people on Earth by tracking those and letting emergency services know what's going on from our perspective.
Speaking of things that you
and hey, if you got the opportunity for me to try to, I'm sorry, do you want me to try to answer that previous question, or should we take the next one?
Sure, that would be great.
So a big question for us is making sure that astronauts, when they get to other planetary surfaces, be that the moon or Mars, especially if it's a long-duration flight like current technology will require to get to Mars, making sure that those people are healthy when they get there, because unlike when we land on the planetary surface, the Earth, we'll have a medical staff there waiting to take care of us. When we get to Mars and start exploring places that people haven't been before, we are not going to have anybody there to help us out. So we've got to figure out exactly what to do to keep people really healthy and what things we can expect them to do to take care of themselves as soon as they arrive.
Well, that's a great answer, and it brings up another question about me. I mean, we're looking at the two of you on the screen right now. You are absolute specimens of health, and I'm wondering how you maintain that health. Let's talk a little bit about your diet. What type of diet do you have, and how much do you feel like diet really plays an important role in your health?
Yeah, diet is very important up here, especially our diet and our exercise are what really keep us healthy. We're exercising about 2 hours a day, and we're on a diet where we're trying to hit a certain calorie amount every day, and we have a tracker, so everything that we pretty much put in our mouth, whether it's a drink or food, we're tracking it on an app that we have on our tablets, and we just kind of can check our progress throughout the day. And at the end of the day, hopefully we're around 100% of what we were supposed to get. And then by doing that over time, then it's going to make sure, for one, we don't lose any weight. So losing weight's not a good thing up here, especially if you lose quite a bit. But it also makes sure, as much as we're working out, we're getting enough nutrition to make sure our muscles and our bones are staying healthy.
If you're just joining us on Cool Science Radio, we're having a conversation with NASA astronauts Shane Kimbrough and Mark Vande Hei, who are 270 miles above the planet and going pretty quickly, 17,500 miles per hour. Gentlemen, this is for either of you. I'm curious about these extensive experiments that you're all conducting on the International Space Station. Do you have a favorite experiment, or do you have an experiment that you're really looking forward to the results?
Well, I know one that I just worked on yesterday that's been going on about a month now, and it's got 2 or 2.5 more months to go, and we're growing chili peppers in space. And so I got to start that experiment a little over a month ago. Yesterday we got a chance to pull it all out and look at all the plants and actually thin some out in order to give all the nutrients to the really healthy ones, and they're all looking great. So here in a couple months we're hoping to have a harvest and get to eat some chili peppers.
Well, congratulations on the chili peppers. A quick question. We've got just about 30 seconds left. Have you been able to witness the space flights of the civilians, Richard Branson and Jeff Bezos and their traveling companions?
I personally have not, but I am cheering for them because we need those commercial space flights to be a success. That's a great agenda of NASA and to cooperate with folks, because we want there to be a space industry with people going to space, and NASA's going to go ahead and hopefully lead that frontier further and further out into the solar system.
Shane and Mark, we want to thank you so much for joining us this morning on Cool Science Radio. We wish you continued success, and maybe we can talk again sometime, but thank you very much for joining us on the program.
Station, this is Houston ACR. That concludes the event.
Thank you to all participants from Cool Science Radio. Station, we are now resuming operational audio communications.